All right. So, hi everybody. Welcome to the ONOS TST meeting. Today we're just going to. Can everybody hear me? Okay. First of all, before I launch in there.
Yeah, we can hear you.
Okay, good. So today we're going to provide. When I say we, means we're going to be primarily Ray and myself. Provide an overview of the ONOS build, as well as a small demonstration of how it works. And this is primarily to give developers a heads up of what to, kind of a peek at what to expect starting with the end of the hour release. Well, all of these things that I'm going to be demonstrating are already checked in, so developers can certainly try them for themselves when we're done. So, first of all, okay, what is Bazel? Well, Bazel is just like Buck, except better. And so, why, if it's just like Buck, do we want to use it? How exactly better is it? Well, let's go over some of that. So we primarily want to do this because the Bazel community is much more active than the Buck community, at least from our vantage point. This is a project that was seeded by the Blaze Code from Google, and it continues to be backed by Google. And the Bazel itself is much more flexible to be able to support various things that we need to do for ONOS build and packaging without having to create custom plugins for the build tool itself. This is something that we had to do for Buck, and this is one of the reasons we got kind of stranded on a custom form of Buck, because we got to a point where it was just too expensive to catch up with the latest and greatest of Buck, and so and it was difficult to upstream the features that were required by ONOS to properly assemble it, and so we basically got stranded, and it's at this point in time really expensive to catch up. So while Bazel is definitely slightly slower than Buck, but it doesn't really help if Buck is faster if it's not as reliable as Bazel. Also, Bazel has much more rigid guidelines and incentives within the framework to make sure that the builds are set up to be hermetic and repeatable. Of course, it's still possible to write them as non-hermetic, but it's much harder to do than it is with Buck. Also, Bazel has been set up from the get-go to work easily with multiple different repositories. So you can, for example, set up the build rules or the definition of build rules in various Bazel files in separate repositories, and to compile projects across separate repositories. Kind of a set of slightly less important but still quite important motivations are the fact that Bazel has much better support for the integrated developer environments out there. They have an official plugin for IntelliJ IDEA, which at least I've been using and Ray have been using for a while, and we find it quite good. There's also an unofficial plugin for Eclipse, which there was nothing of the sort for Buck. Basically, we had to still continue to retain the POM files in order to support developers being able to develop code in Eclipse, and that's, in my opinion, way too high of a burden. So this move, even though it's not stated in this slide, this move will allow us to finally deprecate and actually remove, not just deprecate, remove the POM files within ONOS code base. The Bazel has also much better support for shared remote build cache, which will allow developers to share the results of the build, and this will significantly reduce the build times between developers or between workspaces of one developer. There are existing reusable rules for building various kinds of things, like for protobuf, gRPC, etc. Again, something not necessarily available from the get-go by Buck. I've already mentioned that it makes it easy to build code based on definitions of rules from external repositories, and also using artifacts built in other repositories. And so all of these things, clearly make Bazel much better tool than Bug. And another kind of a motivation for us to move to this is that this will also make us use the same build framework as other projects within the ONOS framework, like Stratum, for example. So this is why we're doing these things, just in case anybody's wondering. And so what does it exactly mean for developers? Also, when we did this board, we tried to keep things as kind of minimal as the changes as minimal as possible, at least from the viewpoint of the developers. Clearly there were, anytime we would come across some complicated concoction in a bug, we definitely try to simplify it. So there will be changes because of that. But for the most part, as you will see, the developer use model should remain pretty much the same. Bazel uses build files instead of bug files, but structurally they're nearly identical. They're both written in Skylark. Building and running of building code, testing and running ONOS locally is done via Bazel command instead of via bug command. But again, usage syntax is nearly identical. Both offer, the build, test, run phases as well as query capabilities. Not yet, but we will definitely, when it's ready to go prime time, we will change the bash aliases in ONOS accordingly to make it switch by default from bug to Bazel. The custom code, instead of being located under bucklets, is now located under tools build Bazel in various .bzl files. I can provide a little bit of a view of that during the demo. And the build byproducts, at least locally, there's a local cache. Those are stored in various Bazel directories, which are effectively symlinks to this private cache that each workspace or developer has, rather than being put in the backout directory, which is located directly under the workspace. So here are just some basics. This should look very, very familiar to everybody. Instead of bug, you just substitute the word Bazel in there. You can build entire ONOS, you just say Bazel build ONOS, or the old alias OP will suffice. Similarly for running it should look nearly identical. And again, the alias is the same. Running unit tests is slightly different. In order to find all of the targets that are tests, we have to run the Bazel query and then basically invoke all of the resulting targets using Bazel test. But never fear, this concoction has been simplified to the same OT alias as before. So as you can see, hopefully it shouldn't be too complicated to switch as a developer. Now, one thing that we simplified greatly, as you may recall with bug, it was extremely arduous to be able to publish the ONOS artifacts into the local M2 repository. Now, why do why would you want to do this? Well, imagine you have an application which is built using Maven and needs to build against the APIs that are built using a custom ONOS build. Because using official ONOS build, you could probably just point to the default central Maven repo and build things that way. But if you wanted to have the application be able to access functionality that's been tailored within ONOS, you will need to first publish the artifacts that you built, the ONOS artifacts that you built using bug or Bazel. And so to do this, you would say ONOS publish, and this will basically catalog everything that needs to be published, and it'll publish it either into local M2 repository, as in this case, or we will use the same command to publish it to Maven Central if you specify an upload URL. And so this will allow and will work much faster to publish those artifacts. Here's an example also of building the kind of a smaller target, let's say specific application like DHCP. the structure of the targets is identical to what it is in Bug, in the sense that you specify the path to the package, and then there's a target within that package. So hopefully this shouldn't look too scary, and should look familiar to people using Bug before. Here is a small example of a build file, and again, this ought to look extremely familiar. We try to keep all of the macros or rules that ONOS had, that were custom to ONOS, to be identical in arguments and names as they were with Bug. So here you can have an example of a build file which builds a jar, a bundle, with also with running, be able to compile and execute tests with certain compile dependencies, which depend on core, on cryo, some CLI, as well as serializer and distributed primitives bundles. And then out of that jar, it can then assemble an ONOS application into an OR file. Again, very, very similar to what exists in today's Bug files. The one difference is we follow the Bug guidelines, which is using double quotes instead of single quotes. One nice thing about Bazel, which I didn't mention, is also that it has much better support, much better tooling for enforcing conventions like quote formatting and structural integrity of these build files. Ray can maybe talk about it a little bit later during the demo.
I mean, technically, sorry, Thomas. Technically, the language is Skylark, not Python, and they've actually restricted the set of stuff that you can do in Skylark. It's not. It's a subset of Python and a subset of Python's APIs.
Did I say it was Python? If I did, I misspoke. Yeah.
No, I mean it's just reinforcing the statement you're making.
Got it. Yes. Thank you. Yep. And please, Brian is also very familiar with this, and he's working on this from the Stratum. And so, Brian, please jump in if I misspoke sometimes, or if you want to add information that I may have left out. So the basic demo, let's do that really, really quickly here. We're gonna build ONOS first, and let's start from scratch here. Can everybody see the terminal well enough?
Make it a little bigger. Yeah, there you go.
Is that right?
Yeah.
So again, that will be very, very straightforward. It will be just Basil build ONOS. The thing is, I've actually just built it already, so I probably need to change something. One thing you should notice, so this is a no-op build. I haven't changed anything, but I've built ONOS before. The no-op build is much, much, much faster than this with Basil, than it is with Bug. And that is because with Bug, even though it has a Bug daemon that can run in the background that facilitates faster reruns, it was very unreliable and subject to corrupted cache and everything else. With Bazel, it also has a built-in server, which I don't believe you can turn off by default. And it makes it much, much simpler to use and much faster to use for no builds. But let's say if I were to...
Tom, there's actually a timeout you can give as a parameter when you're starting up Bazel, which is how long the server should live for. It's like an idle timeout. And I think if you set that to 0 or negative or something.
It will not start.
I think so.
I see. Okay.
But you can. I mean, you could simulate it by basically setting it to 0 or 1 or something as well.
Right. So
it's a startup action.
Yeah. So what I'm going to do, I'm just going to change some file. Let's say in an application here. Let's say I'll change something in an API. Sorry, I'm not in an API, in an app. So here I'm just gonna go, for example, change something in DHCP app API. Let me do DHCP API here.
And by the way, what you can see what Thomas is editing here is actually built using the Bazel files, not the POM files. So that's why the layout is slightly different and I think more concise than the way it was laid out with the POM files. Yeah. Like that directory that shows up, the org.onos project.dhcp, that would get spread out over multiple categories. With the POM file generator, I think it's much more concise with the Bazel one.
Right. So I've modified the file, and if I were to rerun this again, you can see that it just builds the API, the implementation of the application, and reassembles the ONOS package. And that's basically, so this is how you can see it does the selective build. And so a small change, results in a small build time. Of course, if I were to change something a little bit further upstream, let's say, let's change something in a device object. I'm gonna, probably not this one. I probably ought to change something.
You just add a type.
Yeah, that's a good idea.
Or private variable.
Okay. And then if you were to rebuild, this should rebuild the API, but because the API has changed, this will cascade into a build of number of things that depend on ultimately depend on the API. As you can see, this will significantly increase the scope of the build, but again, this is highly parallelized. The number of threads that are going to be used to build this basically depends on the number of threads available in the system. And what I mean is, I think there's a formula. In this case, it seems to correspond to the number of cores that I have plus some factor.
Yeah.
I don't know exactly what the formula is, but for my quad system, this is 8 threads here.
Yeah. You can see there's a lot of references in the output here to Darwin-Sandbox. So for Bazel, this notion of hermetic builds is extremely important. And a hermetic build basically says, think about hermetically sealing something. You have a wrapper around your build, doesn't allow any influences from the outside in. And one of the ways they do that is with this sandbox. They basically, every time Thomas invokes Bazel here, it's creating a special directory under a special hash in temp that the build runs in. The build does not actually run in his directory. It runs in this other directory. And they use chroot to isolate your build from the rest of the system. So for example, you can't get the files in your home directory. You can't get to /temp. There's a lot of things you can't get to. And we found in the buck build that we had a lot of bleed in from external files into the builds, which means that different builds on different systems will produce different outputs. So it's a bit of a struggle at first to kind of wrap your brain around this if you're doing something a little hairy, to find out how to reference all these files. So for example, if you have a file that's an external jar file, you can't just reference it from the file system. You have to map it into Bazel via a rule and then make a dependency of that rule on whatever you want. And the sandbox will make it so that you have access to it. So from the running it perspective, this is great because what this does is this basically guarantees that anyone on any system running this will get the same results. The other really nice thing about Bazel is that for some of the things like Protoc is a good example. We actually use a C binary as the compiler. Bazel has notions of host and target built into the tool. So we don't have to go and download the right Protoc compiler like we did for Buck. We just reference the Protoc rule. It knows we're on a Mac. It knows our target is Linux. Bam, it just does it. So that again makes this notion of the hermetic builds much, much easier to accomplish.
Sorry, where's the Protoc binary hosted in this case? Where does Bazel get the...
I don't know. I don't care. It just works.
It.
It's somewhere on GitHub.
The Protoc binary is built locally. It downloads the sources for protobuf and pretty much any binary that you need, and then builds them locally for your system, caches them, and then you never have to build them again.
So, so I guess the first time ever you build something with protobuf using Bazel will take longer because of
exactly a little bit longer. It builds pretty quickly though.
But and again, this is something I can when this is finished, I can also show. We're starting to make sure right now we can use the remote build cache or disk cache because let me talk about it too a little bit within a workspace. Within each workspace, there is this cache that's kind of a local cache, and you can think of it as kind of a secondary cache or pass-through cache. So if you don't have any other configuration about shared cache, that would be the sole cache. But if you have, for example, separate disk cache or remote cache, which can be configured using the Basil Rc file, then the local cache will be used basically just as a pass-through. And that can significantly reduce the build times too. Because imagine that I have checked out the latest on master, I've built it, I've paid the penalties for building it. But then, then Ray, 2 minutes later, checks out the same commit hash and runs a build. His build will go much, much faster if he shares the same remote configuration, because all of the, let's say, protracted compilation of an open config model, which you can say, right, you can see right there on the top line, takes quite a bit of time. That will be entirely avoidable. Now, we do still have, the reason I said we're still working on this, because even though they're hermetic builds, right now they still don't produce, there's still some leakage. Because we, for example, rely on tar files, and tar files, silly. The contents may be identical, but metadata for each file entry is still poisoning the artifact. For example, the owner group and the permissions, or sorry, the timestamp are still resulting in slightly different hashes for those artifacts, even though the files are, once they're laid on the file system and eliminate the metadata, they're identical byte for byte. So we're trying to still figure that out to make sure that they're 100% repeatable.
The other thing to keep in mind is that for the Buck, since we've been using it for a while, Brian made a lot of sort of build time optimizations to make things run faster, which we have not yet done for Bazel. There are certainly opportunities for that, particularly in running tests in parallel. And there's a lot of work on this within the Bazel community. And my hope is that Bazel will come up with a solution to this, and then we won't have to worry about it. What I'm specifically talking about is when you run tests, and tests include things like check style, each rule spins up a new VM. And that's really expensive when you have thousands of tests. And so what Buck did was Buck had this sort of neat way of keeping VMs hanging around to run tests. Brian took that same idea and extended it for things like checksum, check style. I'm really hoping that they put that into Bazel, and then we can take advantage of that without having to make a lot of changes.
And our policy with respect to helping and contributing back to Bazel is now, before let's say we needed to do something, and Brian, do you want to give an example with a P4 on this?
Yeah, sure. So basically the policy is upstream first, use later, and work around with generals in the meantime. And so, for example, there's a feature for proto libraries, which enables you to specify the sources root, which is not equal to the workspace root. For example, a lot of projects like to put their protos in a directory called proto, or they like to nest it somewhere deeper. And then they, within there, have like a longer path, like P4 runtime, blah, blah, blah. And really, when you're using these files, you don't want to have the whole fully qualified path that's built off the workspace root. So there's a flag in there, but it doesn't work when you have dependent protos. So like it works kind of for one library, but then doesn't work at all if you like inherit from other libraries. It doesn't work with generated protos. So basically, we're stuck with using the workspace root as the proto sources root as well. And we're currently working on some fixes to make this work better. In the meantime, what we have to do is we have to use generals to copy these files virtually into the root of the workspace. So there's some hackery around the way we do protos today, but in the future we hope to be able to do things more cleanly, but we're not going to do them more cleanly until we can get a binary from the Bazel community to sort of ensure that we don't get this fork divergence problem.
Yep. Great. Thanks, Brian.
The other thing you'd mentioned before about the number of cores, so your machine is a quad core machine, but it has sort of 8 virtual cores due to hyperthreading. And Bazel basically just looks at how many cores you have and uses 1x, the number of cores.
Okay.
It is possible to change the number of cores if you don't want it to use 100% of your CPU resources using the -j command or minus jobs. So you could say Bazel build -j space 1 space ONOS, and it will just use one CPU core.
I see. Perfect.
That might be useful for testing machines where there's 40 cores or something.
Right. Yeah. So that not all 4 of them get gobbled up. Not all 40 of them. Yeah. Okay. So that's that. Let's take a look at what the Basil RC file looks like.
I have a quick question.
Yes.
For the protobuf rules, can you specify the version of protobuf of protoc you want to use?
Yeah, because what it does is it like Brian was saying, it basically, what they've done in Bazel is they have a built-in notion of external repositories. One of the sources for an external repository is GitHub. So you can basically say, here's my project URL, here's the branch I want you to pull.
Okay.
Just go.
So in this case, we reference the specific release tag in protobuf. All right. Perfect. So and this makes me think. So right now for P4, we checked out the P4 compiler output for our P4 programs like fabric.p4. So we check out the BMV2 JSON and the P4 info. This makes me think like if so right now the P4 compiler doesn't have a Bazel build. For example, if someone contributes a Bazel build file for the P4 compiler, then we could think of building the P4 compiler having the P4 compiler as a dependency of ONOS, and then building the P4 programs as part of the ONOS build. Is that correct?
Right. So
Exactly.
How do you do with VM models, for example?
Yeah. The other thing you can do is this notion of these external repositories. They allow that repository to not be Bazel compatible. And then you can specify in your tree, here's the Bazel build for that source. So if we were willing to write that, we could actually compile within our build their sources.
Okay.
So yeah, in general, that's a pretty good way of getting started without needing to work with the upstream community. In this particular upstream community, I've been working with Antonin over the last couple months to start putting these build rules in a lot of the P4 repos. For example, there's a check-in that is either going to land, has already landed or will land today, that'll add native Bazel support for P4 runtime. There's also progress for the PI repo, which has the reference implementation of P4 runtime, C++. And then there's, I think if we were to ask if we could put it on P4C repo as well. Yeah. Antonin's already sort of built up some familiarity with this and is fairly receptive to getting this stuff on these various repos. So I would encourage you to work upstream in this particular instance.
Yeah, I agree.
And so while we're sort of on a subject, but not specifically to P4, but with subject of sharing the rules. So today, all of the custom build rules or macros that we use within ONOS code base are within a ONOS code base. They're located under Tools Build Bazel. So if I were to collapse this Tools Build Bazel right here, this is where they are. They're a mixture of BZL files, which are the Skylark files, which define the rules, as well as some backing Python scripts that are used to actually perform some of the activities, some of the actions, I should say. Now, we expect these to be exported into a separate repo eventually, and the reason for this is so that they can be used by developers not working directly on the ONOS code base. This is effectively to facilitate the next step of facilitating ONOS code base desegregation. Because what we're looking at is taking the ONOS core and splitting it away from some of the more peripheral pieces of ONOS code, like some of the protocols, drivers, some of the applications, and basically making sure that they have their own repos. But at the same time that they can still use the same convenient mechanisms to be built. So
Thomas, can you show the depths file to Carmelo? Just so
yes,
you can
yes.
see how these things get put in. Oh,
It's the generated one, I think.
the generated one.
Generated
Oh, sorry.
workspace or whatever it's called. It's the thing that gets spit out by ONOS LibGen.
Let me.
So in this case,
Sorry.
if we go to the like if you search for a protobuf. This is the Java library, but keep going.
It would be above it, I think, what Brian wants to see. Probably wants to see where it's fetched.
Really?
Yeah, it should be up at the top.
I was at the top.
There.
This is
no.
well, this is the group.
Yeah, keep going. It should be. It's not there,
It's
huh?
not here. Oops.
Well, now nothing's here. Yeah, there it is.
I'm not sure what you're looking
No,
for.
there it is. That's how it's downloaded. I don't know if that's what Brian was referring to.
No. So what I wanted to show was that external workspaces can be imported using a native rule called HTTP repository or HTTP archive, a new HTTP archive.
Bar something, Thomas.
Okay.
Maybe it's in a different. It might be in a different Bazel file. Sorry, I might have gotten refactored since I last looked. But the point is that you give an external workspace a name, and then everyone within the project or within this workspace will refer to it by that name. So, for example, if everybody uses the same name for protobuf, like Tom, Google, protobuf or something, then you can update the version in one place and everyone gets a new version.
I see.
If you want different versions of the same external workspace, then you just have to give them two unique names and then have some rules depend on one name and some rules depend on the other name. Obviously, that's non-ideal, but it's certainly possible if you need to support, say, two different versions of the same workspace.
There you go, Brian.
So here,
pulled up the file that I used to download the P4 stuff.
Yeah, so if you look at line 15, native HTTP archive, this is saying, hey, go fetch a remote workspace. Its name is the one that will be sort of used to refer to these artifacts within this workspace. And then, as Ray was saying, there's a special URL for GitHub that you can use to download sort of a snapshot at the given tag, branch, or commit hash. So if you needed two versions of it, you just need to have two HTTP archives with two different names, and then rules would need to refer to the different names. But ideally, there's just one version of the remote, and it's something that's close to master.
And for the Protoc stuff, they even abstract that away. So you tell the Protoc rules what versions you want, and it deals with all this stuff. You don't actually have to deal with downloading the sources; it does it for you.
Okay, so in this case, why are you downloading the HTTP archive for the Protoc compiler? Protoc?
Probably it's a leftover. We may not actually need it anymore.
Okay.
A lot of this stuff I have to go through. The P4 stuff in general is really shaky. Like gRPC doesn't work.
I'd be happy to,
Yeah, I know.
Sorry, what's the question is for the HTTP archive? So this one here, this HTTP archive is actually a zip file that contains all the sources, and this would be as opposed to doing git clone, where you get the whole commit tree.
Oh, I see.
But I think
so. This is
Carmelo's right. I think we actually download the sources twice because I think the Protoc rule will also download this stuff.
And same thing for
where?
Right?
Where?
The Google RGC.
No, those I needed that's to get the proto files.
Oh.
The other ones.
Yeah, the third one is for the proto files. The second one is for PI, which is moved to P4 runtime repo.
Yeah.
And the first one is for protobuf.
Okay, well, I think it's time for me to take a look at this.
Yeah, this stuff all has to be reworked. And like I said, gRPC, there's also a set of rules that I've been working with to try to get it to work. Doesn't work yet. And I think we probably still have, there are some places in the tree, I think, where we just P4 compile things, right, without gRPC. I haven't tackled those.
I'm not sure. You mean we just use the product compiler? We don't P4 compile stuff.
We don't. Okay. Okay.
We always check in the P4 compiler output.
Okay.
So I think pretty much the P4 and gRPC stuff is pretty much the only thing that's outstanding to have support for Bazel. Because this is the modules BZL file, which is very analogous to what we have with modules def for Buck. And this is basically kind of a set of groupings of artifacts that we need to build as part of the ONOS project, right? The utilities, the API, the various core utilities. And you can see that if you ignore the web GUI 2, which I'm working with Sean, starting to work with Sean to get that done, it's just the protobuf stuff.
Yeah.
And you will see here there's the...
Yeah.
It's just primarily just a P4 runtime that still remains to be done.
Okay.
Also, there's some of the OpenStack stuff needs to be done too, but because they have a lot of custom...
Sona has
they have a lot of
custom inclusions and stuff.
Yeah, so we need to work those out. But for the most part, you can see that we have pretty good coverage for what needs to be done still.
Yeah. So STC runs, by the way, with these generated binaries. The running ONOS local with the UI works. So most things are in pretty good shape. It's the P4 gRPC. That's what's.
And Ray, if you want to put in place something to test that, there are actually a few scenarios on STC.
I know. I remember that you saying that. I haven't looked into them because I don't have enough support yet. I was also kind of waiting for you to come back from your trip, so we could figure out what the right way to do this is. The good thing is that Brian's been working a lot of this stuff in parallel for Stratum. So I think if the three of us get together, we can figure out a strategy to get this working pretty quickly.
I don't know if this is probably on a different topic, I don't know if you already discussed about this, but does Bazel facilitate the process of developing ONOS applications on the same machine locally while referencing your ONOS master repository?
Yes.
It should.
If I understand.
Yeah. The nice thing is that what you can do locally, if you want, is you can refer to local repositories or local workspaces. So what I've done in Stratum is when I want to use a custom version of something else locally, you can these rules are set up so they can be overridden, and you override them in your top level workspace file. You add a reference to the local repository you want to reference, and then just provide a partial, relative or absolute path to that. So if you're working on an app and you need to depend on ONOS, normally you depend on just the latest release of ONOS. But if you wanted to work against latest master, you could just add a local repository line, use the same name that your dependency would normally refer to, and then it will just use the local sources on your machine.
Sweet.
It's actually really, really nice. This is something that Buck really, really couldn't do. It didn't like sort of any notion of anything that wasn't hosted as like a binary remotely.
Yeah.
But you can just have sort of some modifications to your local workspace file.
And I think we should update the application tutorial that we have to make sure it captures how to do it through Bazel for the build and maybe an archetype for the app. In theory, should be no change, right?
The Maven stuff should just work.
But I just want to make sure I understand your question correctly. So the building through Maven, the supporting of Maven archetypes, we still assemble those using Maven archetype plugin. But are you asking about whether or not, as part of the archetype, we should be able to include means to build the application using Buck?
No. I'm saying that we should be able to tell people how to post locally the artifacts that are needed for them to build upon.
Correct. Yes. Yeah.
It was just probably adding a couple of commands to the application tutorial.
Correct. Yes. You're right.
But it's important to note that if you want to use Maven as your build tool for your app that is located outside the tree, then using the a mechanism to publish the artifacts locally to your MT repo is what you'll need to do. If you are using Bazel to build your application, then you don't need to publish artifacts anywhere. You can just directly refer to the local repo on your machine.
Exactly. Yes.
Yeah, so you would load ONOS as an external. I mean, we could do this too if we published all this stuff, right? You could they could load it off GitHub. Isn't that true, Brian?
Yeah, so the idea would be that if you wanted to write an app and use Bazel as your build tool, we would provide, as part of the archetype or something, a deps file, which would refer to sort of probably the latest ONOS release. Now, if somebody wants to build off a later branch, they can override that pointer, that remote workspace, with a local workspace that points to their locally checked out ONOS tree.
Yeah. We could even extend the ONOS app rule, I think, to be able to put in an ONOS repo identification in there, like the way Protalk does, and just have it do all of it for you.
Nice. Very nice.
We'll see. I don't know if people are going to want to build. People like to use Maven, so I don't know. We'll see.
So here, I've ran ONOS locally using the Basil run, as you probably saw. And we're currently building 148 apps. I think the total, if you were to run it using Buck, I think the total is like 172 or 173. So we still have about 25 apps to go. But again, it's mostly OpenStack and P4, various P4 modules and drivers.
Okay.
So I think once we get the P4 and gRPC rules set up, that should hopefully snowball fairly quickly.
So for example, I was planning a refactoring of the bug rules for the P4 stuff because they changed the structure of the P4 runtime repo. So I should probably focus on
doing
that. I would say
because our goal is actually, and I realize this is aggressive, but I don't want to build OWL using Buck.
Yeah.
OWL will be built using Basil, and Buck will be deprecated. And after we release OWL, the POM files that you see in ONOS code base will finally be gone.
Wow.
We'll take them off. I think only one or two POM files will remain, and that will be the ONOS dependencies POM will remain, and ONOS base will remain. So, but the top level one and all the project level ones will vaporize.
Right, and I will focus on doing that with Basil.
Yeah, because the reason there is, it may seem harsh, but they're just way too much baggage we're dragging around just to basically just facilitate the development ID Eclipse. And right now there is maybe not an official way to build Eclipse, import Eclipse projects into Eclipse, but there is a way. And so we're going to rely on developers to figure it out, because it's way too much cost to the community to maintain the POM XML.
And the way they do it, the way that the Basil guys do this stuff, I think is actually I like the way they do it a lot. So the program, Basil, is in tight cooperation with the plugin. And so rather than like what the POM one does is there's code in IntelliJ that processes all the POM files. The way they do it for Basil is the plugin actually invokes Basil with some special arguments saying, hey, generate the junk I need for IntelliJ. So all the Skylar code is interpreted the same way. It's really nice. And I don't know what your experience is, Thomas, but I found it to.
Same here.
It's much slower to load because it's got to run everything. It's basically running a full build for you. But it sets everything up really nicely.
And you can debug unit tests and all of that stuff.
Yep.
It all works from the bug, just out of the box.
Yeah.
Which even with bug, we've had issues with that, right?
Yeah.
Because the bug plugin had some issues with properly separating the production time versus test time.
Yeah.
So dependency graphs, and that resulted in some cyclic dependencies, which were really just phantom. They were not there, but Buck thought they were there. You can. So this is the default Basil RC file. It has basically a couple of options enabled by default. Then it kind of shows the syntax for enabling either disk cache or remote HTTP cache. Now in ON.Lab, I should say at ONF here, we have actually set up a remote HTTP cache using Nginx. And currently it's still experimental. We're still trying to work out some of the kinks, not with the cache itself, but with our build process, producing repeatable artifacts which are free of some of the metadata junk, which changes the hash. But I think we're near the cusp of having that stuff ironed out. So I don't want to be rambling for too long. Is there any questions from the community out there? Nope. Okay. And do you guys have anything else to add? Brian, Ray?
What's the deadline? Or,
Well, so kind of projected release date is in 2 weeks for OWL. But in the past things have moved probably like maybe a week or two sometimes. But definitely I would like to, towards the middle to last week of August, I would like to, or third week of August, I would like to have a release. And we may, which means we still have to tackle some of these extraneous projects. But for that, we also going to rely on the community. So, for example, I plan to get in touch with some of the Sonar community from SKT to help support the bug to Bazel files. And if that doesn't happen, or if we don't manage to do it ourselves, because there's still a little bit of convolution involved, that may mean that Sonar will not be included as part of the default build. I think there will continue to be a custom build. The bug files will still be there. We just won't be using them for official release.
Okay.
And if that means we're gonna run, ours gonna run with slightly reduced application payload, well then that will be it. But I don't want to run it using bug anymore.
Okay.
Because you need to be a little bit more aggressive about pruning the dead wood, honestly. All right. So again, all of this is on master already. If you were to look, you can see that that's available for everybody. What I was showing you. So I encourage the developers to give it a go, start using it, and see if they can help discover quirks or gotchas with this. I will also send an email to the ONOS dev list sometime today to do this with a pointer to today's presentation, and hopefully we can get this going with more people.
Okay.
Right. If there's no other questions, I think we can call the meeting closed. And we'll see you in 2 weeks. Going once? All right. Bye, everybody.
Thank you.
Bye.
No, thanks.